Hey everyone, in this video we want to solve problem 354, Russian doll envelopes, which is a hard problem. In this problem we are given a 2D array of integers envelopes in format wi and hi, which wi represents the width and hi represent the height of each envelope. And the task is to find the maximum number of envelopes that we can put one inside the other, which is called the Russian doll. So, for example, if you're having an envelope of size 1 and 2, you can put that in the envelope of size 2 and 4, but you cannot put that in an envelope 2 because the widths of these two are equal, but this envelope would fit in the other envelope of size 2 and 4. So for example, here I show you I have an example of a Russian doll of size 5. So we have, as you can see, the first envelope is here, 1, 2, 3, 4, 5. So in order to solve this problem, there are a couple of ways. One of them, you can use a dynamic programming, but it would cost at least n squared. But we are given the maximum length of the envelope of size 10 to the power of 5, or it is 100,000, we should go with a problem with a better performance of the order of n log n complexity. So for that, let's say we first sort the envelopes that we have. So using sorted function in Python and then envelopes, what do we have now? So given here, let me just print that, or sorted array equals this, and then just print sorted array. Let me just return none for now, just to see what we have. So initially, sorted function just comparing the objects in the array by their values, and if the values are tuples or lists themselves, Python by default comparing the elements first by the first element of that those lists, and then if in case of equal, like as you can see here, when the first elements are equal, then it compares them by the second element. So now we have 2, 3 first, and 5, 4, and then 6, 4, and then 6, 7. So now we make sure that these are already sorted by the width, the envelopes already sorted. What happens if we drop, let me disable and enable that again. What happens if we drop the width from these envelopes and then only consider the second item, that is the height of these envelopes? If we find the longest increasing subsequence in this new array, that means we already have the confidence that these envelopes are already sorted by the widths. So this one, the width of this one is less than the width of the second envelope, then it is less than the width of the third one, and so on. So we should only find this one, find the longest increasing subsequence in this new array. So in this case, it would be 3, 4, but we cannot put this envelope of height 4 and the envelope of 6, 4. But what would happen if we swap these two envelopes? So these are equal in widths. Both of them has the size of 6 in width. But if we swap them, we would have 7 and then 4. So in this case, the longest increasing subsequence would be 3, 4, 7. That envelope of size 5, 4 actually fits inside 6, 7, and the answer would be 3. So in order to change the criteria of sorting, we can use we can pass a function to the key argument in the sorted function by we can either implement a function ourselves or use an inline lambda function. I would use lambda e and then return e0. So the first parameter is fine. We want that to actually compare the objects based on the first element, which is the width of envelopes here, but reverse the order of the envelopes if they are equal. So if we have two or more than two envelopes of equal weights, then we want to sort it in decreasing order. So we're just putting a negative sign here, and then sort. So let me run that again. So this is what we want. So now these two are swapped, and then the problem would be if let's say we implement a longest increasing subsequence of a given array, and then for this one, I just wanna drop the first element and then only consider the second one, which is the height of them. So E1 for E in sorted array. So this is actually what we want. Return the longest increasing subsequence by dropping the first parameter in these arrays and just considering the height of these envelopes after sorting them with the criteria that we just implemented. This problem is actually on LeetCode as well. It is repeated on problem 300, longest increasing subsequence. So for example, here, what is the longest increasing subsequence in the second example? So if we take 0, 1, it is an increasing subsequence. But if we go further and pick 2 and 3, so these four elements, if we take them out, 0, 1, 2, 3, is an increasing subsequence, and the length of that is 4. In order to solve this problem, let me write down an example here. So let's say you're given 0 and then 1, -1, 3, 2, and then 5. So in order to solve that, so let's say we iterate through the items. We first visit 0, so we would just put a 0. And then we have multiple sorted arrays. After that, we visit 1, so we put 1 here. Then -1. Is -1 greater than, is a subsequence? Can we put that on the right? No, because the order matters in the subsequence. So we create a new list. We keep track of that here. And then after that, we visit 3, so we can put 3 for both of them, because -1 and 3 is a valid subsequence, and also 0, 1, 3, another valid subsequence. After that, we have 2, so we cannot put 2 appended into these two lists that we have here. Then we create a new one, and finally, after we visit 5, we just put 5 for all of them, because 5 is larger than the last element with all of these lists. And the length of the answer for this problem would be 4, because this is the longest subsequence that we found. But in order to improve this problem even better in terms of improving the memory usage, we can use the same. So we visit 0, and then we visit 1, we put that. So we have, instead of creating multiple lists in the memory, let's say we want to have a single memory in a single array, which is always sorted. And when we are visiting a new element, like here, a new integer, a -1, we first compare the new element with the rightmost element in the list, which is 1 here. Is -1 greater than 1? No. So that means we should find the index for that in the element instead of creating a new one. And why is that? So using a binary search in log n, since we know this array is sorted, we can find the index of that and then update the value. So here in this problem, what matters is to return the length of the increasing subsequence, not the elements themselves. If we keep track of the multiple list, at the end, we could have returned that we found a subsequence of 0, 1, 2, 5, and we have the length of that and the elements themselves. But here, since the length of that only matters, we know that after visiting 3, if let's say we just remove that, replace 0 with 1, with a -1 and then 1, we find the index for put the -1 using a binary search. And after that, we visiting 3, we can add 3 to the right. But at the same time, although it is not a valid subsequence, we know that since 3 is larger than 1, 0 was already less than 1 because it was sorted. Although we dropped that, still this it is somehow representing a previously visited subsequence from the previous iterations, because 1 was larger than 0 and then this array was sorted. But the, the thing that we are updating, that removing the 0 with -1, is that we want to somehow reserve -1 for potentially finding another subsequence in the further iterations in cases that the -1 value actually is important. So let's say, for example, if we had, instead of -1, a -10, for example, and then we finish visiting all elements, and then it turns out we have a -9, -8, -7, and so on, we have them in the list. So we find an array of size 4 here until this iteration after visiting 5, but eventually we find that we have new smaller elements, and then we are updating them and then putting them here, and then we potentially can find a longer subsequence and return the length of the array, not the elements themselves. So if you're confused, let's go to the implementation and we can see what we have in mind. So initially, since the answer at least a single element itself is a valid increasing subsequence, right? So we have array, and then this array is always sorted. So we have num 0 at least, and then iterate for num in from the second element in the list. If num is greater than the last element in the array, so it's fine, so it is good, so we just append it, this new one. Otherwise, using a binary search, we should find the index, binary search, in order to put this new num in the array. So to put the num in the array. So one way is to, if you don't know what binary search is, given a sorted array like A1, A2 till AN, let's say we have a new element B, we want to put them, we know that A is already sorted and we want to put B in this array. So we take out, we compare it with the middle element. So we break the whole this array into two sub-arrays, left and right. And then we compare B with this middle element AM. If B is greater than or equal to this value, so that means we can discard the whole left portion and then repeat this procedure on the right sub-array. And so on. So at each iteration, we are discarding half of the array, and then we can put the element, we find the index in log n for n elements. And hopefully, so fortunately in Python, there is a built-in function that implemented in, if you import bisect, so from bisect import bisect, discard bisect left, but I will change it to binary search. And then so this would be, this is everything that we want here because it is already implemented in Python. So I would update as we discussed. So I would update the value of this index with the new num. And then finally, we just return the length of this array because it keeps track of the maximum subsequence, and the length of that is the answer that we want. Okay, so that's fine. Okay, so we solve this. And what I want to do is to just copy paste the whole thing that we have from this problem. But in LeetCode, the solution class would be used, so I'm going to rename it with problem 300. So let me remove these two as well. And I want to create a new instance. So here we want to use a longest common subsequence. We want to use this function from this instance of that class. So this whole thing is equal to the longest increasing subsequence that we wanted to use. So, and I hope this is everything for this problem. Okay, so that was everything. I hope you enjoyed and used these two problems. In this video we solved two problems back to back, and I tried to keep that short. Hope you enjoyed it.